Hello and welcome to this next lecture on fundamentals of acoustics. We are looking now at interior acoustics. We started with the rigid walled box and now we are looking at interior acoustics of a cylinder, and we are at this point where we are looking at the behavior of Bessel functions and looking at the shape of the mode inside the cylinder. So we were looking at the behavior of J1. Okay, so J1 starts off at a 0, goes through a maximum, goes through a 0, another maximum 0, and so forth, and decays. Okay, so the J1 means m equal to 1. Okay, so its first peak occurs at the Kr phi a value of 1.84. The next peak occurs at Kr phi a value of 5.33. Okay, that means what? Inside the cylinder, if I have a J1, I start off with a 0. Okay, and then I have a peak at the wall. Okay, and m equal to 1 means I have one diametral node line. Okay, why? Because it's cos m phi and therefore cos phi. So if I go around the shell along the circumference in the angle along the angle phi, I will get one node line. Okay, 1 0. So on one side there will be a plus, let us say, on the other side there will be a minus. Okay, and because n is a 0, okay, this shape rotates. Okay, this peak rotates around. So there are no nodal circles. There are no nodal circles. Okay, this shape over here actually rotates around, can be accommodated around the shell, and therefore this represents a line which becomes a nodal circle. Okay, so this direction gives me the diametral nodes, the diametral nodal lines, because it is cos m phi and I go around phi, and this direction gives me nodal circles. This shape gives me nodal circles. Why? Because J1 of Kr phi r has to be rotated around cos phi. Okay, so wherever this has a 0, it is taken around, so that becomes a nodal circle. Okay, so for n equal to 0, no nodal circle. N equal to 1, n equal to 0 is here, n equal to 1 is here. Okay, now in the middle there is a node point, 0 point, so there will be one nodal circle. Okay, so now I have a, so let us see, I have a, let us say, a plus here and a minus here due to cos. Now further, due to the nodal line, I mean nodal circle, I will have a further division. So this will become a plus, this will become a minus, this will become a plus, and this will become a minus. Okay, I start off with a plus, I move around, I cross the nodal diametral nodal line, I become a minus. I cross this again, I'm back to plus. Okay, there is a phase change, and the opposite happens in the inside of the first nodal circle. So for n equal to 2, and m equal to 1, I will have one more nodal circle and further phase changes will occur. Okay, that is how this picture looks like. So now we have acquired the value of kzq. Okay, so kzq, let us see, kzq is q pi by L, and kr phi of course is wherever jm dash kr phi a becomes 0, you pick up that value kr phi into a and then you divide by a if you want the kr phi value. Okay, so let us say we have for m equal to 1, the first one n0 is at 1.84. That means kr phi, whatever be the radius, is equal to 1.84, and therefore kr phi is 1.84 by a. Okay, so now kr phi has two indices, right? Kr phi has an m index based on the order of the Bessel function and the n index based on which 0 you are going through. Okay, so now I have kzq and I have kr phi with m and n indices. Okay, what else is there? Now here during the derivation, what did we do? We had here k square minus kz square, which is my kr phi square, right? I have k square minus kz square, which we call the kr phi square, or my kz square plus kr phi square is equal to k square. But now because of the finite nature of the cylinder, okay, it is finite in the radius, finite in the z direction, many eigenvalues and eigenfunctions have come up. Therefore, I have now kzq square plus kr phi square mn are equal to now k square, but this has to have index to k square mnq. Okay, so now kzq is q pi by L, so I have q pi by L whole squared and whatever value I get plus k square mn r phi whatever I get is k square mnq, which I write as omega square mnq by c square. Okay, and let me take this to the next page. So this omega mnq I now write as twice pi f mnq, f now in cycles per second or hertz, all squared by c squared, or square root of q pi by L whole squared plus k squared mn r phi, or let me write it as k mn r phi squared is equal to twice pi f mnq by C, or FMNQ, which is the resonance frequency now, which is the resonance frequency of the FMNQth mode, is equal to C by 2 pi square root of Q pi by L whole squared plus K M N R phi whole squared. Okay. Now, just as we did for the rectangular box, let us try to look at some modes. Okay. So, let us see, I have Q here, then I have M and N, then I have F, M and Q. Okay. Let us say L is 1, L is equal to 1, and I will take A is also equal to 1 for simplicity. So, let us say Q is 1, let us say Q is 1. Okay. Then M is 0 and N is 0. Okay. So, F, M and Q, and C again I will take as 300, C 100, or C by 2 pi is 50. So, I will take C by 2 pi such that it is 50. This is 50, value 50. Okay. So, I get 50 into Q pi by L. Q is 1, pi by L, let us say 3 into 3 is equal to 150 hertz. Okay. So, Q1 looks like what? Q1 in the Q and R plane, Z and R plane, if I look at it, this is my Z. Okay. This is my radius. It looks like this. I have a plus here on this wall, I have a minus here. So, the mode actually looks like cos pi Z by L. To Z equal to 0, it is Z, Z equal to 0, and this is radius equal to 0. At Z equal to 0, I have a maximum goes through a 0. At Z equal to L cos pi, I have a minimum. Okay. And if I look at it in the from this side, it is plus, and if I look at it from this side, so okay, let me correct this. If I look at it from this side, it is a minus. Okay. And similarly, if I look at it from this side, it is a plus. Okay. So, now let us look at again Q is equal QMN, QMN, FMNQ. Let us say 0, M is 0, and let us say N is a 1. Okay. So, along the RZ plane there is no change. Okay. R and Z plane there is no change. It might just be whatever. Okay, we will see that. Along this circle now, what do we get? We have M0, so no diametral line, N1 gives me 1 nodal circle. Okay. So, if I call this a plus, I will get a minus. Okay. So, here. So, I will get a minus here and here, I will get a plus here. No change along the z. Okay, I suppose you got that. So if I draw this here, if I draw the circle here, then I will cut here, I will cut here, cut here. So I get one nodal circle. Let me draw it properly. So in parallel, if I draw, okay, this is the z direction, then this thing cuts here, this cuts here. So in between I see a plus, here a minus, here a minus, and no change along z. Why? Q is 0. Okay, let me just try one more. Suppose, okay, so what would be the value here? M0 and 1 is 3.83. M0 and 1 is 3.83. Okay, so so I have 50, then Q is 0, so I get square root of K M N R phi into A is 3.83, but A I have chosen 1 for convenience, so A is 1. So K M N R phi itself is 3.83. So I have square root of 3.83 squared. I will take it as 4, approximately 4. So this is 4. So 50 into 4 is equal to 200 hertz. Okay. So let me do one more. If I have Q equal to 1, then I have M equal to 1 and then I have N equal to 1, then my F, M and Q is 50, let us say square root of Q is 1 pi by L. So pi by L is, let us say 3 square, plus now M equal to 1, N equal to 1. What is that value? What did I do? M equal to 1, N equal to 1 is 5.33. So I have a 5.33 squared. Okay, this is let us say about 9, this is 25, 26, let us say 27 approximately. Okay, 5.33 squared, I do not know. Then sum of this is 36, root 36 is 6. So I have 50 into 6, that is about 300 hertz. And how does this look like? I have an M over here which is 1, so I will have one diametral line plus minus, and N is 1, so I will have one nodal circle. So this will be plus, this will be minus, this will be plus, this will be minus, and okay, so if I take a cut over here, so I will see a plus over here due to this, but because Q is also 1, Q goes like this, Q has a plus minus, so this will be a minus. Okay, and now if I look at this part, this is a minus, so I get a minus here and it will be a plus on this side. Okay, Similarly, if I am taking a cut like this, okay, here I will see a plus, here I will see a plus because of this plus. I will see a plus over here and a minus over here, okay. And if I am actually taking a cut like this, I will see this part of the minus also. I will see that this part of the minus also. So I will get a line over here which is minus and a plus. So this is the cut I have taken in the shell to see where what the sound field is. Okay, if I cut off the cylindrical shell and open it here, I am open to this plus, so that is the plus, but along Z I have a plus minus, so this will be minus. Then I will be open to this minus is over here. The opposite plus happens due to the Z variation. Similarly, here I will see this plus, this same plus over here, okay. Then I have a plus and a minus, and finally if I open it here, I am open to this negative pressure here, so that will give a negative and a positive. So that is the picture. That is how you should understand how these interior sound fields look like, okay. So now let me close the lecture here and we will continue along these lines in the next class. Thank you.